Now, geometric optics no, is our study no, of how no, images are created either in a flat mirror or no, sometimes there are mirrors that are purposely no, made curve. Uh, there are uh, there are mirrors that if you would want not to zoom your face no, or to enlarge your face, they use this mirror called a concave mirror. No? Now, so again, no, geometric optics is a branch of optics, and optics is the study of light. So this is a special branch of optics no, that focuses on how a virtual image or a real image no, in front of a mirror no, is formed. No? So paano natin mabalaan nga ang aton tsura sa mirror will be like this. No? We are not enlarged or we are not reduced. No? How will we know that? No? Again, we studied the geometric lines there on how they are traced. No? So I believe no, in this study, I think you'll need a ruler. Maybe you'll need some French curves, no, so that you can draw properly, no, some curve lines, and a lot of also, no, it will require a lot of tracing, no. So you are able to realize, no, the where the image is probably located. Now, applying the rules, no, on our geometric optics, no. So one is that light flows no as a flow of photons that has some wavelengths, no. So if you consider red no up to violet, then they have their own sets of wavelengths, and they're comprised of no this corpuscular no particles called photons. Now light rays travels in straight lines. So if we have no an infinitely far no source of light, no, then we believe that each of them no are traveling no parallel to one another no in a straight line. No? So hindi pwedeng ang light no when you beam it, you're able to make it turn no in a corner, because light does not behave like that. No, it will simply travel no straight. No, so you cannot use it no to search for things that are located on your right, because you really have to point it right so that it can beam not to the right. No, you could not open your flashlight straight and expect it to turn right or left. Okay, when you also cross the light beams, no, so you have two flashlights, you cross them. Now they will never no collide with one another. So they will simply no pass each other, but no, they will not influence the path of the other one. Light rays also obeys the law of reflection. No? So we already explained the law of reflection, but it also no, follows the law of refraction. And law of refraction no, is that when light enters two different sets of media no, or material, no, like from air, it enters water, no? Or it enters a glass, from air to glass, then light will kind of bend. No? It will bend somehow no, in the direction, no? Because it will either speed up or slow down. No? So when light no, travels from one medium to another medium, no? There's always a change in its speed, and then therefore no, light will bend no, in the process. So that's refraction. But the reflection again, we just mentioned that it involves two principles within the law of reflection. Light rays travels from light sources to your eye. So it travels straight. So if you see a bulb, if the light of the bulb strikes a surface, that surface will reflect light and eventually enters your eye, and you are able to see things. Now, the principal objective of geometric optics is to be able to determine the location of an image. So if you have an object, say you stand in front of the mirror, so you consider yourself as the object, and the thing that you see in front of the mirror is known as the image, no? And usually it is standing behind, no? Behind the mirror, no? So again, how that image is formed, how far it will be from the mirror, no? And so on, no? Will it be enlarged? Will it be reduced? Is largely now depending on this principle called geometric optics. Now, last time or sometime, probably no, many instances siguro no, that you've visited an optical shop. We always think of an optical shop as a store, no, where it sells eyeglasses. And again, that may be true, no, because they do sell, no, eyeglasses, shades, and so on. But optics, no, or optical is all again, no, referring to light, no. So it speaks about light, no. So again, optics is a discussion on the amount of light, no. So inside our eye, no. So we have this optical nerve, as they also call it, no. So that optical nerve is critical, no, on whether we see or not be able to see things, no. So if something is will damage that optical nerve, probably, no, we will lose sight also, no, of our sense of sight. Okay, now next, no, images are formed, no, one by sketching, no, ray path, no. So what we usually trace are incident rays, and now we trace also the reflected rays. Now somehow, no, with the intersections of these lines, images are eventually formed, no. And likewise, there's a very important equation that we also use here, no. Or no, we will probably also learn, not so that we will correctly, no, know the image that is formed, no? And that is known as the mirror equation, no? So the mirror equation is important, no, in knowing, no, where the image is to be found, no? Now we have several types of mirrors. One type of mirror is the flat, no, plane mirror, which is largely found, no, in all of your homes, no. So most likely in each of your houses you have larger plane mirrors, you have smaller ones, no, but definitely you have at least one mirror in your house. So you won't know, no, how you dress up, how you would look, no, if you have no mirror in your house, no. So I think, no, it's more of an advantage rather than, no, simply, no, a convenience or a luxury, no. It's very necessary, no. Now aside from these plain or flat mirrors, we also have these curved ones, which we can probably consider as spherical mirror. I even heard of cylindrical, no, cylindrical mirrors. But then again, no, they use the same purpose, that mirrors can allow, no, you to appear smaller, or can make you, know, appear bigger, no? So depending on what type of a spherical mirror you are using, no? Now in terms of the lenses, now there are lenses that can converge light, no? It can make light group together, or there are also lenses that can spread the light, no? So if it's a kind of a lens that will spread the light, usually we call it as a diverging lens, no? The kind of lens that will group together light and concentrate it, no, is known as a converging lens. I think at one time, if you have seen, no, a glass lens, no, so the many years ago, no, so those kinds of lenses are available, no, and you can concentrate the light of the sun, and maybe, no, if you play with it, no, you can even kill some ants, no, by concentrating its light. So maybe, no, you can think of that concentrated light and that very intense amount of light, no, that even, no, ants that are walking, no, can literally, no, be zapped or killed, no, by that intense light as a converging lens. So you can concentrate it. No? Now, however, no, aside from that one, no, you can also magnify uh, characters or words. No, so especially if they are written now with small characters, you can read them. No, and then you can read them clearly. No, if you use some lenses. No, just like eyeglasses. No, or that lens again. No, you can put it on a document. No, and then you can read it much more clearer. No, with less effort. Other uses are telescopes, microscopes. No, lenses can operate and magnify very tiny microbes, no, or microscopic cells. No, you can magnify them several times, no, with the aid of uh, a magnifying lens or a microscope. No? Now here's again the nature of our reflection, and again we call the angle of incidence as probably letter I, the angle of reflection as letter R, and their value are equal. No? So that's with regards to the law of reflection. No? And then these three lines that we have, the incident ray, the normal line, the reflected ray, they all fall in the same plane. No? So all those two, once they are satisfied together, then you have then you can call that as a reflection, really. No? So, but if one of them is violated, then that is probably not following the natural reflection of light. No? Or maybe that phenomenon is not reflection at all. No? Now here's an image that is seen by a plane mirror. No? So you have here a jar. I don't know, it appears like a jar. No? And it is placed in front of the mirror. So most likely, since the image that we are seeing is of the same size and height as the one that is placed in front of it, that maybe we can say that the mirror here is a plane mirror. No? Now, usually, the image that is created is behind this mirror, and we call that image that is found behind the mirror as a virtual image. I could even call our session as a virtual meeting, because if I'm going to let display all your faces in the screen, you are all behind my computer screen. You are found behind the mirror, behind the screen that I have. So whenever you are located somewhere behind the what could probably be considered as a screen, if you're found behind it, then that could be a connotation of virtual. So imaginary or virtual is the word that we assign for an image that is found behind this mirror. Now, some of the flat or plain mirrors are used to make a room wider. So you can make a very tiny room, spacious. You can create that illusion to the people that are in that room, and then they will feel relaxed because the room seems to appear wide, because some walls are placed with this very wide, very large plain mirrors. So if you look at the room, the room would seem to extend. Maybe it would appear as though it is an extended kind of a room. So the room would appear spacious with the help of a mirror. Now this kind of mirror, I think they call this one a specular reflection. Now, how are images created in a plane mirror? So one is that there must be some amounts of light. So one, from this candle, that candle is a source of light. So some light is incident, or there's an incident ray that strikes this plane mirror. Now the shiny or reflective surface of the mirror is facing or near the eye. No? So once it strikes this reflective surface, this this light now, no, that is incident will now reflect to the human eye. No? So that's why, you know, you are probably able to see the lighted candle because the reflected light now goes to your eye. Now, but what about the image that is behind here? No? How is this produced? No? Now, the reflected light will probably go in this direction, but somehow, no, we can extend that line, no, of reflection backwards. No? So if we trace this line of reflection backwards, maybe we can think of this line as going in that direction. No? So this is the extended part of the line. No? Now, another light, no, that could probably appear here could come from the head of this candle. No? So it could come from the head of this candle. And then, or yeah, no, maybe, no, or maybe it is coming from this direction. No? Okay, again, no, one is a light that could probably come from here, no? And then it could also, no, reflect back. So ang aton nga extended line, no, if you will extend it behind, no, then maybe, no, this is the reflected line that we have. And we see that it will intersect at this point. No? Now, the intersection of reflected rays usually, no, creates now our image. No? So the image is an eventual, no, intersections of two or more, no, reflected rays. Now, there is a distance from this, there's a distance, no, from that candle, no, to the mirror. No? And usually, no, the candle is considered as your object. So you have here the object, no? And it has a distance from the mirror. No? So we call the distance of the object from the mirror as the word, no? The word is object distance. That's the distance of this candle, the real candle, no, from the mirror, and we will label it with a variable letter P, no, to denote it, no, as again, no, a specific distance. No? Now, from the okay, so again, no, the distance from the mirror to the object, which is the candle, and the distance of the image, no, which is behind the mirror, is labeled as Q, whereas this one is letter P. No? Now, they may be in a unit of meters because they are both distances. No? Now, for a plane mirror, the values of P and Q, no, if it's in meters, they should be the same. No? So that's the distinction of our, no, our plane mirror. No? So again, as a result of the intersection of the ray of light, no, then we get, no, the formation of our, no, our image. Okay, so let's clear this. No? So let's move on to another slide. No? So how are they formed? Again, no? They're formed, no, behind the mirror. So the word for images that are formed behind the mirror, we call them as virtual, no? Virtual images. Or if you want, no, you can call it as imaginary image. Now, question, can images be formed in front of a mirror? No? The answer is yes. No? So as a matter of fact, there are devices that are able, not to project the image. No? Pwede mo siya nga i-flash sa wall, no? because they are being projected, because they are found not behind, but they can be made no sa front no sang mirror natin. However, sometimes no, you will not recognize the object because the image is inverted. Nagbaliskad siya no. Now because of the inversion or the no, so it's not upright no, it's not ang yaulo, it's not up but it's down. Sometimes you will not recognize the image no, so you will have a difficulty no identifying who that is no, or what that is, because what you did not realize is that the image was inverted no. So in order for you to be able to visualize it no, then you must design something no, that will allow the image to be no reflected no in a manner nga it will go upright no. So you will make some changes to that no, so the image now will now straighten up. Okay, so this is the creation of images in a flat mirror no. Now, for our spherical mirror, we have two types now of spherical mirror. We have concave, convex mirror. No? So there are some reflecting surfaces having the form, no, or we cut a portion of our sphere, no, or round object, and maybe put some shiny thing no, on one side. No, if it's a glass, then you are now able to have no a convex or a concave mirror. No? Now, examples of this concave or convex mirror, to those of you with vehicles, check the side mirrors of your car. No? Most likely they are convex mirror. No? Convex mirror, the images that you see there are kind of small, no? But it has a wider angle. You can see a wider portion of the road, no? But no, you are to avoid no or to you have to be reminded no that they don't appear as they are no, because they may look small but in reality no that's a huge truck trailing you or is on your side no. So maybe no you may collide with that car no, not realizing that it's really no bigger than you are no. So they don't appear as they really are no, whenever we are dealing with convex mirror no. Now there are also concave mirrors that some objects would appear no very large no, they are magnified as we call them no. And again no, that's with the thing with concave mirrors no. Now let's see some of these examples here no. Now a lot of that now has to come no with some notations, and I believe no they use this notation P no to denote what we call in our maybe no trigonometry, is that trigonometry no, or our precal no as our vertex no. Others would call this as the vertex no, and denote the symbol with letter V no. But in this example no, I think now the previous notation was it was labeled as letter P, but we've used I think no letter P already for distance no of the object from the mirror no. So but anyway no, we will be dealing with some kind of a vertex, a center no of curvature, and then maybe no an axis no where this vertex and center no are connected. So but let's see no the actual diagram no. So the rays reflected and incident rays no are important no in determining here the image that results no whenever we deal no with these images that are no that are formed. So here is a picture of convex mirror. No? So again, no, convex mirrors are those that are found in your vehicle. So in your car, no, the side mirrors, they contain convex mirror. No? If you enter or go into Iloilo Supermart also, I would observe this in Iloilo Supermart. No? They have these convex mirrors that are positioned at the top, no, overhead. So if you go in their inside their grocery area, you'll see a lot of these convex mirror that are placed, no, overhead, no, sa may uluhan sa babaw, no, on the ceiling, no. Maybe it helps those people, no, that are watching the customers. Pwede nila ma-monitor, no? You can monitor them because you can look at the different alleys and sections of the supermarket without really going there, no? So by simply looking up, no, you can check, no, how are the stocks, or how are the customers, no, doing, no, on that side, no? Are they doing fine or not, no? And maybe, no, you can respond according to the need, no, without really, no, going into every alley, no. So again, no, the purpose of a wider angle, no, of the convex mirror, no. Now, if the shiny part is in the curve area, no, so you can stand in front. You can call yourself here as the object, no. So this one is your object. Maybe that's a candle. So if you are inside this curved portion, then that curved portion or the shiny part there could now make this mirror concave, no? So whereas this one, no, you are outside, no, of the curved part. So this is a convex mirror. And then again, no, usually you appear smaller here, and then you appear, no, with a bigger, no, angle of vision, no? Now, what are the things that we see? Again, letter P here, no? This capital letter P, you can call this as the vertex of the vertex, no, or the pole, no. So that's the intersection of the actual mirror, no, to this horizontal line or the principal axis, no. So you have here letter P. Now C is your center of curvature, no? So if you make this into a single circle, so this letter C is the center of this huge circle that we can simply cut, no? So amo nang iyang center. Now, therefore, the distance from C to P is actually a radius, no? Now, since we do not have a circle anymore, this is just a portion of a circle. So you can call that as the radius of curvature, because this is merely, no, a small curve, no? So radius of curvature is the distance from P to C. Now, if you get half of that, no, then you can identify another point F, which we call as our focus. So the focus is halfway, no, halfway, no, in your radius na distance, no. So meaning the distance from the center to F is 1/2 the radius. Another word for that is the focal length. So the focal length is half of the radius, or twice the focal length is equals to R, no? The radius of curvature. Now that goes the same way, no? Here on the right side. So this intersection could be called V or P, no? And then again, no, the focal point and then the center of curvature, no? Again, if the reflecting surface lies inside the curve, what you are dealing, no, is the concave mirror, no? Sa sulod din, no? Okay, so again, this horizontal line, the black horizontal line that passes all the points, center of curvature, focus, and principal, ini ang aton nga vertex is known as the principal axis. So focus, no, is your halfway point, no, in your radius. Wait, now perhaps, no, this concave mirror, if you'll try to get, no, the characteristic of the light as it strikes the concave mirror. Now, we believe that if light comes, no, from a very, very distant location, So the source of light being the sun. No? The sun can be considered as a source of light from infinity. No? Now that light, now that comes from the sun, now we believe them to be parallel to one another. No? And so much so that they are parallel to the axis, no, of this mirror. No? So if they all are parallel, no, to the principal axis, they will all reflect, no, going into the focus or the focal point. No? So they will all concentrate at this point, no, in gathering, no, all this light from infinity. No? So again, we know that these lines travels in straight lines, no, but once they reflect back, no, they will all be concentrated to the focus. Now that is used, no, by several devices like antenna, like in ang satellite dish. Why is our reception, no, when we get a subscription, no, for our cable TV in your house and you use this dish, why is the signal very clear? Because again, no, all the signals that are transmitted will all be collected at the focal point. No? Okay, a ray of light that passes at the center will go back, no, to the center. No? So here, no, this is a typical example when light, no, is dili siya maagi sa center mo, no? So once it reflects back, no, it will go back at that same path. So how will that appear? No? So maybe like this. It will go back at exactly the same path. No? So this is your reflection. No? So when they come from infinity, they will all concentrate at the focus. When it passes the center, it will return back to the center. Because we believe the center to be perpendicular, no, to your surface. No? So any light that strikes the mirror, no, perpendicularly, no, then it will be returned, no, in that same line. No? Okay, so let's check the next slide. No? So let's clear this one first. Okay, so what if our ray of light, no, again, passes the focus, no? So another possibility is for light to pass the focus, no? And the focus again is halfway in our figure. What will happen to the light? Now, where will the light go when it passes the focus? No? So if assuming, no, at some point there's a light here, no, that definitely just simply passes the focus and strikes the mirror. No? Now you'll notice that that light will eventually reflect, but the question is, in what direction will it move? No. Now we will do the reverse here, no? And again, no, if a while ago, if light is coming from infinity and they are parallel to the axis, they will all concentrate at the focus. Here, the light will now, no, be reflected parallel to the principal axis. So light will be going, no, in this direction, no, from the mirror going left. Okay, follow? Okay, and then if they will now go to the vertex, no? So you will have a similar angle, no? That will now be formed. No? So the reflection will have I equals to the reflection. So this is how the last one. No? So a ray of light which strikes the mirror at its pole, no, or at its vertex, no, reflected, no, according to the law of reflection, where I or R are equal to one another. No? Okay, so case 1 na to, no, is when object, kung ang isa ka object, ibutang natin sa center mismo, no? So maybe this is you or it could be anything, no? So we can think of it even as a block, no? So if you stand here, no, for example, at the center, basically, how will the image, no, form, or where will the image be found, no? So again, no, we follow some ray of light, no? So what happens now when an object is placed exactly at the center of curvature? And maybe we will just take this one case now and determine again now the image that is formed. Now, as an image, light can definitely come from it. No? So one light could be this light that is parallel no, to the axis of, sorry, no, so that's not it. No? So one particular light is this light that passes no, the head of this object and strikes the mirror no, parallel to the principal axis. Now remember, the principal axis is this line no, at the bottom. No, this one, no, inidio. Amo na yung principal axis nato. No? Now, if the light is parallel to the principal axis, that light will now reflect and it will go no, to this location. No? So it will reflect passing the focus. No? It will pass the focus. No? So this green colored ray is your reflection. No? So again, no, any light that is parallel to the principal axis will always reflect itself to the focus. No? Now again, no, for us to form an image, all that we need no, is an intersection or intersections of reflected light. No? Now another light probably that we can consider, no? And maybe we will just have the red color. No? Now is this one. No? So from the head of this image, we could have a light that will pass the focal point no? Or the focus. No? So once it passes the focus, we know that the reflection no, will be going no, horizontal or parallel to the principal axis. No? So let's change the color of our arrow. So the reflection here will be parallel to the axis. And you'll see now that there are now two green lines that meet. No? We now have two green lines that meet. No? And where are they? No? So again, no? Right here at this location. No? So at this location, we see that the two reflecting rays intersect there. No? So therefore, if you'll now try to draw an image here, no? Then maybe the image is kind of inverted. So if we put the head no, on the intersection of the green line, then no, we will have an image here that is now inverted. So but it is still found no, at the center. No? So we can describe the image as of the same size. No? It is real. No? So we don't use the word virtual anymore for images because it is in front of the mirror already. No? So if this is the shiny part of the concave mirror and it is found no, in front of the mirror, then our image no, is described, number one, no, as real. No? Real, again, when it is in front. No? It is in front of our mirror. No? Now, another one is that it is inverted. So look at the head. The head is on the other side, no, downward. And then, no, same size. No? It's not enlarged, it's not reduced, but it has basically no, the same size. No? So it's real because it is in front, it is inverted, no? But no, it is of the same size. So again, no, images in our no, images formed no, by our spherical mirror. And in particular, this is a concave mirror. No?